Okay, let's talk about my final project. This is about the security aspects of cloud storage, the access control algorithm. Let's first talk about cloud storage itself. Cloud storage can provide user with data sharing service. In the era of big data, cloud storage has become a mainstream of data cloud storage. Cloud storage is a cloud computing model that stores data on the internet through a cloud computing provider who manages and operates data storage as a service. It's delivered on demand just in time capacity and costs, and eliminates buying and managing your own data storage infrastructure. This gives you the agility, global scale, and durability with anytime and anywhere data access. Therefore, the security of cloud storage has gradually become more important. Before the security of users' sensitive data can be ensured, data owners and users also need to use the services provided in the cloud environment. Among the access control is the most important method to protect user access data, and it's also my research focus. In cloud storage, data files are mainly stored in the cloud server, and the data owner cannot always supervise the access of data. After handing over the access rights of sensitive data to cloud server, if a sufficiently secure access policy is not established, then the data in the cloud server will be maliciously modified or leaked at any time. Therefore, attribute encryption is particularly important in cloud storage access control, and attribute encryption is also a basic guarantee for improving the security of sensitive data. So those are the recent researches in this field. I just The first is the research of PKI identity authentication based on blockchain by Chen Wuyang, and here are the following researches about this topic. Um, they have already proposed some useful um, like the access control algorithms and the modified version, but I think they have still have a lot of things that I can improve and need more future researches. So my first I'm going to improve the cloud storage access control in the following three aspects. My first proposed solution is a traceable attribute encryption scheme based on signature authentication, which can track users who leaked information. In the cloud environment, the user key is closely related to its own attribute, but the specific identity information cannot be viewed. When the information is leaked, the issue of specific identity information leakage cannot be traced, and the responsibility of authorization center or the users cannot be determined. The user's private key can also be illegally authorized to other users. Therefore, a traceable attribute encryption scheme based on signature authentication is proposed, which mainly prevents the leakage of other users' key through the unforgeability of signature authentication, can effectively track users who leak information. The scheme is able to distinguish the responsibility of the users or the authorization center. Secondly, I proposed a policy revocation scheme based on the attribute encryption, which enables users to revoke policies more flexibly. Policy revocation plays an important role in cloud storage access control. The policy revocation scheme can make the cloud environment for the storage and the transmission of users' data more securely. However, in general policy revocation schemes, there is often a problem of difficult user management. Therefore, I propose a policy revocation scheme based on the attribute encryption and uses an improved ciphertext-based policy attribute encryption scheme to encrypt the sensitive attribute data in personal health record. In addition, considering that the policy is revoked in the attribute encryption scheme based on the ciphertext policy, a new key needed to be generated for authorized user. The owner of the personal health record updates the list of authorized users by changing the attribute policy. When the policy is revoked in the personal health record sharing system, the trusted authority calculates secret part of the secret token key according to the policy update level and issues the updated key for the new policy. This solution puts more emphasis on the key management part, policy management part, and the user revocation, and fully controls the data owner according to the policy update level selected by the data owner. This solution can help personal health record owner and users to flexibly revoke policies, and it can also avoid a lot of time loss. Thirdly, I proposed a user attribute revocation scheme based on the improved attribute encryption, which enables data owners to reduce computational overhead in the cloud storage access control. When faced with more user attribute distribution problems, the workload of the data owner will increase exponentially, and the revocation of users' attribute will be jointly decided by the data owner and the investment center. In the traditional user attribute revocation, the user's private key also needs to be updated, which will affect the execution effort of the access control strategy in cloud storage, and the attribute encryption effect of the ciphertext strategy. Therefore, the therefore my project proposed an effective ciphertext strategy-based attribute revocation scheme, which mainly encrypts the plain text through asymmetric encryption technology, and then when user attribute is revoked, the authorization center generates a new version of number key, and the updated version is handed over to the cloud server, and the ciphertext is encrypted again through security certification and performance analysis. This solution can reduce the computational cost of data owner. So in conclusion, the three schemes to improve the access control scheme in cloud storage. The first is the attribute encryption scheme based on the signature authentication. Plays a role of accountability. Second, the policy revocation scheme based on the attribute encryption can avoid unnecessary time loss. Thirdly, the user attribute revocation scheme based on the improved attribute encryption can reduce time overhead. So those are my three proposed solutions for my topic. Thank you so much.